Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to talk about what we learned from the AWS outage. The Wednesday before Thanksgiving in 2020, AWS had an interesting outage that we want to investigate a little bit more. And AWS has been very open on what's happened. They published their service logs so you could see everything that's happened. So on November 25th at 2020, at 3:47 a.m. Pacific time, they were updating the East region. And all they were really doing was just adding a little bit more capacity to one of their services. So adding more servers, storage, network, what you would normally do when you're starting to run near capacity. So they're going to add a relatively small number of servers to the Kinesis service. Now, Kinesis is an interesting service. It's a service that does pattern matching on log files, on video files. So it's an AI service. And it's a very useful AI service that a lot of people use. And about an hour and a half into upgrading these servers, alarms began firing and errors began coming up with Kinesis, the Kinesis records. And it took them until almost 8 a.m. in the morning to find out what root cause caused it. And the root cause here was actually very interesting. The first, what they found, Kinesis has several different smaller services, a group of front-end services and back-end services. And they were upgrading the back-end services with a larger server pool. And in that server pool, as I added more capacity, more servers, the front end, the way it's architected, for each server on the back end, it would spawn a new thread to communicate to the back end, the front end to the back end, which is a very common way of architecting a system like that. Anytime a new back end service is up and running, a thread fires off on the front end. Well, one of the problems was that the front end fleet of services and the OS that they were running on was configured to handle only a certain number of threads. Once I hit that number of thread threshold, then the front end began to fall over. They figured out that real quick, made some updates to some OS, a temporary fix, and Kinesis was back online by about 10:30 p.m. later that night. So we're talking an outage that was substantial, almost 18 hours. It took that long to recuperate. Now, some of the things that they did to recuperate from Kinesis falling over was to move the back end to larger servers, which decreased the number of front end threads that needed spun off. I know they're making additional changes to the architecture, so it's a little bit smarter about spinning off threads and things like that. Patches to the OS configs, things like that, or some other things too. Everything was back to normal approximately at 1 a.m. Pacific time. So we're talking a good 21 hours that Kinesis was not fully operational. And you'd say, okay, Kinesis, an AI tool, not everyone uses it. But it's what uses Kinesis. And this is where the impact of Kinesis going down is what I really want to talk about. So if we look at everything that uses Kinesis, there are several other Amazon services that use Kinesis. For example, Amazon Cognito is tightly coupled with Kinesis, and it was overloaded until about 2 p.m. Pacific time on that first day. So Amazon Cognito was down. CloudWatch, tightly coupled with Kinesis, because Kinesis goes through logs determines what alerts are in those logs, and then notifies CloudWatch. Well, CloudWatch was no longer getting information, and but CloudWatch is architected pretty well. So they had a way of in the architecture of running disconnected, but not for 20 hours, running disconnected for a half hour or an hour or something. So some of the buffers in CloudWatch started overflowing. So CloudWatch was down until 10 p.m. That night. Another interesting thing with CloudWatch, there are a lot of services that depend on CloudWatch. So with CloudWatch down until 10 p.m., that also affected auto-scaling policies. It affected Lambda, which is, Amazon, one of Amazon's premier services for function as a service. The event bridge was down. Even their container ecosystem with ECS, EKS were down during this time until around 4 o'clock p.m. on that first day. So you can see kind of the cascading effect that one service had on several of the other services. Now, this was only in the East region that the outage happened. And but what's interesting about that is they learned from what they learned in that East region with it going down, and they went through and they made some changes to the other regions so Kinesis would not fall over in those regions. They added capacity. So they changed the size of the machines so they can handle more for the back end of Kinesis and things like that. But if you were a user in the East region, you normally rely on some really important tools to tell you the health of your infrastructure and the services running in that infrastructure. One is the health dashboard, and then your personal health dashboard. And this ended up being a problem because the service dashboard and the personal service dashboards were not getting information anymore. So it was showing everything is green. So if your services were down, a lot of IT shops were investigating, why is my stuff not working? Because I look at the dashboard, everything's working fine. So they were getting false positives. So there were a lot of IT organizations that went through and were looking at their own logs and then helping investigate what really happened. So it was kind of a wild goose chase for some of those IT organizations because they weren't getting the right information. I've been very, very surprised at how open AWS has been about this whole thing. Like I said, you can go out and take a look at all their logs, all their service techs and what they did to overcome this. It's a great learning experience. So let's take a look at some of the lessons learned that Amazon learned and that we can learn from going through this ourselves. So one of the first lessons that we learned here was that simple operations to infrastructure, like increasing capacity, need to be understood and planned out. Now, I'm not saying the AWS just did this off the cuff. They obviously didn't. But they didn't fully understand what the impact of this would be. So even though we have done things like this maybe before, it's always good to run these in test environments and run things to failure in your test environments during your upgrades. Test them, run them to failure so you know where the boundaries are on things. Now, this means it takes a lot longer to deploy things, but it's something to think about when you're doing these deployments, especially on services that are so critical to several other core services in your structure. Which leads to the second thing here. Service-oriented architectures or microservice-oriented architectures, they still have dependencies. And a lot of times these dependencies are harder to find because they're not written down. Someone says, hey, there's a great little service over there that if I send data to and I get data back, it's going to give me like postage. Or in this case with Kinesis, it's going to filter my logs for me and only give me back critical events instead of minutia events, whatever it might be. You've got to understand your dependencies on other services, and if you can, understand what your whole service dependency tree looks like. So when you do have an outage, that you understand where you can start looking for where the problems are. Another key thing here is when you understand your dependencies, that you make sure that you're not completely tightly coupled to that other dependency. You want as loose coupling as possible. For example, with CloudWatch, it was sending log files down to Kinesis, and then when it got the responses back, it would then purge its buffer from those logs that it was sending. Well, since they never got responses back, their buffer overflowed. That was one of the problems with CloudWatch falling over like it did. So understanding that maybe the service on the other side won't always be there. You've got to deal with that as well. So it requires a lot more defensive programming with your microservices. Remember, you cannot rely on the underlying services that you're calling, that they're going to respond quickly, that they're going to respond at all, and that you still need to stay up because other people may depend on you. If these services were written more that way, then it wouldn't have a cascading effect like it did, for example. Another thing to watch out for is to watch out for circular dependencies between services. I have seen this happen before in even some of my own programming, where I've got a chain of maybe 4 or 5 different microservices that are all dependent on each other, and one hiccups and everything comes to a screeching halt, or everything starts spinning really quickly, consuming resources and doing nothing. I've seen that, right? And like we kind of mentioned already, don't assume that your service that you're dependent on, that you will always have connectivity. You've got to write your programs, your microservices in such a way that they can run in a degraded fashion, where I can't communicate to all the services that I have, but that they can still at least say, I am not working. This was some of the problems that we had with this outage, was we didn't even know. As a consumer, we weren't given information because the dashboards were running green, even though we weren't getting any new information. So keep that in mind when you're developing your microservices. Now, there were several companies affected by this outage. And there are several companies, mostly all on the East Coast, including some companies that are owned by Amazon themselves. Companies like Adobe Spark, Acorns, the Washington Post, the Tampa Bay Times, Vonage, RSS, Roku. There were lots of different companies that were affected. Some companies flew right through this outage pretty much unscathed, while others had a harder time recuperating. When I went back and I looked at these companies, I read some of their blogs and did some research with them, made some phone calls. I found out the ones that were able to adjust quickly already had a multi-hybrid cloud strategy, knowing that, hey, if something happens, I can still keep my operation up and running because I have another cloud that I can use as a backup. Now, some of them use just a different region of AWS, while others used Google or Azure as their backups. And then some even said, I just ran it back in my own data center, like my external website, or I ran on my external website. We are currently experiencing problems. So at least they weren't like the 404 can't, not accessible. That would be really bad. Also, the companies that did really well that were hardly saw any impact at all were not using some of those specialized services that Amazon was providing that were affected, like EKS and ECS, which are their managed container offerings, and Lambda. Those were hit pretty hard and were down for a substantial amount of time. So those that weren't using the specialized ones, maybe they were using containers or they were using a fast offering, but they were running it on infrastructure instead of having it hosted. Did a lot better. Now, another thing that impacted a lot was the auto scaling policies weren't working properly for some time. So any company that had a lot of traffic during that time, their auto scaling policies weren't working properly. So they had to, roll up their sleeves once they found out what was really going on, roll up their sleeves and scale up services annually. Now you would say normally during a normal week, that might not be an issue. This was the day before Thanksgiving. Everyone was traveling or everyone was buying online, especially this year with the pandemic, a lot of people staying home. So a lot of people were doing a lot of shopping. Even my wife's own little shop on Etsy. Etsy sales were down that day dramatically. We thought, oh, what's going on with their shop? Now we know. Etsy stayed up, but they weren't scaling as much as they normally could. So there were some decreased sales that day because of this as well. Another important thing that I thought was really interesting, some of the companies knew and actually contacted AWS that there's outages. Those companies had their own external monitoring. They weren't just relying on AWS's health dashboard by itself, but they actually had their own monitoring that were running on their own servers that were monitoring services in AWS to make sure that they were up and running. They knew before most other people knew that just relied on the dashboard. So this concept of external monitoring of your cloud resources and services saved some of these companies. It was very valuable to them. It would be akin to like having the fox in the hen house, watching the hens. You need to take ownership of your cloud resources, much like what you would do with any other utility that you're starting to use. In fact, I had one of my coworkers ask me, what did we really learn from this? And I said, what we really learned from this was that utilities like electricity or telco or cloud are utilities. And we need to use the same best practices that we've been using for decades around like electricity. If I have a data center, or maybe I don't even have a data center, I just have my office working. If I want business continuity, then I have a power generator. I even have one in my house, right? Where if the power goes off, which here in California, it goes off often, right? Then I have a power generator for my critical systems. So why wouldn't you do the same thing for your critical systems cloud? Have a backup. So if the cloud does go down, because we have learned it goes down, and AWS is just one of the cloud service providers. All the cloud service providers have at some point in time in their past had some kind of outages, something like this happen. You want to make sure it doesn't affect you. Having a backup, whether it's with another cloud service provider, in your own data center, if you're using cloud as your primary, then you need a backup. Just like I have a generator for the electricity at my building, right? Or if I put it in a data center, I don't go with one telco. I always go with two telcos. Everyone knows that, right? So you want to do the same thing with your cloud service offering. Two clouds, making sure that you're abstracted away from specialized services. Use them where you can, but also give yourself a backup in case you still need to operate. Maybe you're not operating at full capacity. That's okay. At least you're operating. So those are kind of the best things that we learned out of this outage, and talking to some of these companies on, how it affected them. Some it affected greatly for a whole day. right before Thanksgiving. Others, it was an easy switch over. Not too bad. Not dramatically impacted like some of these. Now, there are lots of information already out there, including Amazon's own service logs. It's an interesting read. It's highly technical. It did cause me to research. I didn't know some of these services they were talking about. Caused me to research some a little bit and understand the dependencies between those. And then there's some other great articles out there on ZDNet, The Verge, Wall Street Journal, Washington Post, all have some articles on there. You can find those out on our blog where all the links and the research came in together. Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and embrace the digital revolution.